10 years ago, after taking a break from Blender development, Brecht came back to the Blender scene with an incredible gift, the Cycles render engine. You might remember this demo. It showed the beginning of something new. It was groundbreaking and set the direction for future development. Over the past 10 years, exactly 10 years today, Cycles has been used in so many ways, has become compound of an artist's toolset. The Blender Open Movie projects, if you remember those, especially this one, helped a lot to push Cycles development, and so did a growing community of developers and industry partners worldwide. Community, renders, penguins. This is Pablo Vasquez, and today I'm joined by the ones and only ones Brecht, Sergey. How are you guys doing? Hello.
Hi.
Hello. Hello to both of you. So, first of all, welcome to the show. I think it's the very first time that we have something like this. We're streaming live with both of you, and it's a very, very special occasion. Exactly 10 years ago, you, Brecht, how old were you when you posted the very, very, very first demo that we just saw of Cycles?
I guess 25, something like that, yeah.
25 years old. I remember a year earlier to that first announcement of Cycles, we were working together on Sintel, and we really wanted Sintel to have global illumination, and then you hacked it in the Blender internal, but we were never really, never really happy with it because it never made it to Blender internal. But then a few months later you came you just appeared out of nowhere with Cycles. So it's been 10 years. Cycles has seen a lot of contributions from the community, has been also used in other softwares, and it's really grown a lot. So we have some celebration today, and we have a thingy by you two.
Yeah, a small announcement. Yeah.
A small announcement just to celebrate the birthday. So, whenever you want.
Yeah, I mean, okay. I guess we'll just start. A few months ago, Ton challenged Sergey and me to do a kind of a research project or something more, sort of a bigger project that we could work on. And so we picked Cycles, and basically we wanted to address some long-standing issues in Cycles. And so what Sergey and I are doing is we're doing sort of a 6-month project to look at the core architecture, look at some of the long-standing issues, look at some of the things that the community wants, and so on, and try to push Cycles forward in a way that it will be sort of future-proof for the next 10 years as well. And so that's what we're announcing today. So I'll just briefly talk about what we're trying to achieve on a high level. It's a very broad goal, but the first thing is just sort of improving the Cycles architecture for future development, so we can more easily add features. Because currently, the code has grown over the years, and there's been lots of contributions, but sometimes we take a wrong direction, or we don't do the design quite right, and now is sort of a time to revamp that and try to set a better foundation. And then more in the practical side for users is that we want to improve usability in a few ways. For viewport rendering, we want to avoid having to tweak all kinds of settings. We want to improve the workflow for things like resumable and incremental rendering. I'm not going to go too deeply into what that means exactly, but we have more details in that blog post. And so another goal is to just generally improve performance on modern CPUs and GPUs. We've had different kernel architectures. We have the mega kernel, we have a split kernel for OpenCL and so on. But it wasn't quite designed right with like the latest hardware in mind since 10 years. Of course, a lot has evolved, and so we're sort of relooking at things to improve performance. And then you hear me now, or
I can hear you now. Yeah. Just before the fourth goal.
Just before. Okay. So yeah, we were talking about improving performance to sort of keep up with like hardware changes in the last 10 years. And then the other thing is we want to do more advanced rendering algorithms for things like volume rendering, for things like caustics, for things like many lights, sort of complex lighting scenarios. And that's sort of the last stage of what we'll try to do with this project. So we started this about 2 months ago, sort of making design discussions, building a prototype. And what we have at this moment is new CUDA and optics rendering kernels that have improved performance. We've worked on viewport rendering. Sergey in particular has worked on that just to improve sort of the interactivity and the performance when you're navigating around in the viewport, when you have denoising enabled, things like this. One big change that I guess you would notice is that final rendering is always progressive currently. There's no tiles, there's no tweaking of tile sizes. It sort of schedules things automatically for you, and it's not slower. It's, there's no performance impact in the way that the current progressive rendering has. And so you sort of don't have to worry about that aspect too much in the new version. Besides that, we're kind of removing some features and that we think are not necessary anymore once we are done with like all our improvements. And one of those is the current OpenCL rendering kernels, which we're replacing with a completely new kernel. Talk about that later, how that will be addressed. And we're also removing things like the NLM denoiser, because the AI denoisers are so much better, and French path tracing we might remove because we think we can do better light sampling that's more automatic without having to tweak manual parameters.
Wow.
And the last thing I want to note is, sorry.
No, nothing.
Yeah. The last thing I want to note is that this current, the current prototype that we have, basically it misses a lot of features, right? It's missing volumes, it's missing the shadow catcher, it's missing multi-device rendering. There's all kinds of things that if you try it, you'll find that your scene might not render quite the same as before, or might be missing some things. So keep that in mind. And so this, I'm not going to go into the technical design, but basically we have sort of a new kernel architecture, a new flow graph of the way we schedule things, and that gives us improved performance, especially on the GPU. And the CPU performance is about the same currently, but so on the GPU, and I'll just talk a little bit about the performance improvements that we're getting with this first prototype. So keep in mind that this is all provisional. Of course, we don't have all the features yet. This is, a particular set of scenes with particular hardware and all this stuff, and we're still working on optimizations, but this is what we have so far on one GPU. This is like a Turing generation GPU. And so these are, some relative speedups with optics and CUDA. And so you can see that some scenes have like a small speed up, like the BMW, but we're getting some pretty significant speed ups on more complex scenes, particularly interior scenes with lots of shaders, scenes where the GPU sort of struggles to keep things coherent, which is important for GPU performance. And so yeah, on this particular GPU, we get like up to 7 times faster rendering on the barbershop scene, and somewhere somewhat slower, somewhat less on other scenes, more on some, it depends on the scene, but it's like up to 7 times faster with this, with this GPU.
So the more complex the more complex the scene, the better the what?
generally speaking, yes. Particularly, interior scenes with lots of light bounces, with lots of shaders, it tends to work. But like if you have a simple scene, it's not going to help as much. But if you have like subsurface scattering and hair and all this stuff, it usually helps.
It's gonna be better. And one thing about this graphic that we're seeing now is that on one side is from 0 on CUDA is from 0 to 100, and optics 0 to 50. So actually these lines would be half the size if they were.
Yeah, I mean, so CUDA is already faster than optics is already faster than CUDA, right? If you use it right now, and so this is so both optics and CUDA are faster than what we have currently in 2.93 basically. And so this is another, like we have, these are the numbers from one GPU from a Turing generation, these from an Ampere generation. Like there's the speedups are a little less on the Ampere generation GPUs. We don't know quite why yet, but we're looking into that thing. But also here you get up to like a 4 or 5 times speed up on some scenes. So that's pretty significant, I think. Yeah. So I'll give it to. I'll just show now some videos from Viewport for Viewport rendering performance. I think Sergey can give a bit of background on what we're seeing. So this is, go ahead.
Yep, totally. So on the one side, you can see the cycles viewport in the current master branch, which will end up in 293 release. On another side, you see the cycles X. So basically, what you can see here is that before the changes we are making, the navigation was way more choppy, and you could see way less of the meaningful pixels. You saw a lot of black pixels around the scene, which was not helping you to orient in space. So with some trickery for the algorithm of how we schedule things in Viewport and how we scale the pixels, we just managed to do way better perceptual viewport for the CPU. This is CPU with OpenImage denoiser, and before the changes we were making, it was very hard to navigate. It was almost unresponsive. It's a bit hard to show on a video, but I was moving my mouse hard during navigation, and sometimes it was just stalling for many seconds. With the Cycles X, it's always responsive.
That's crazy. OpenImage denoiser. I thought it was that's CPU, right?
That was CPU rendering, yes.
Wow.
With OpenImage denoiser.
Wow. Could you?
This is.
Sorry. Could you? A moment. I'm gonna lower the music on request, because I look in the background, but I think it's just what you're saying is just so cool. What you're doing is just so cool. So, here. Sorry. Continue.
Okay.
We
were not very happy with is that it was feeling a bit epileptic with all those pixels, big and small pixels popping almost at the same time and whatnot, and that just didn't feel smooth enough. So we also addressed that. So just kind of to show how the navigation with GPU looks before and after the changes. And I think we also have the GPU. We have. Oh yeah. Other thing is while we were refactoring a lot of code, we noticed that adaptive sampling didn't work in Viewport at all. So that's also been addressed, and as you can see from the picture, it converges way faster, and it converges to the specific noise floor which you asked it to converge to. Wow. And other thing to note is in the topic of removing settings, the start resolution setting is removed, so the system will automatically choose the resolution based on performance of your compute device, taking account how long does it take to render, how long does it take to denoise, and things like that.
Wow, Viewport adaptive sampling.
Yep.
Wow.
So, Okay. Yeah. So now I'll just briefly mention like what's the next stage of the project. So the first thing we'll do is we'll publish the code. We'll make it public. We'll invite other people to contribute. Existing cycles contributor that we've already discussed this with. And so of course users will also be able to test it. But I have to warn you that it's a prototype. There's lots of things missing. Things will render might render differently and so on. So it's very far from production ready, let's say, and have to be sort of careful when testing it. So the plan for us is one thing we'll continue doing is working on more GPU optimizations. Like we have, of course, we have a nice speedup already, but we have more ideas to make things faster. So we'll try this out. We don't know, how much we'll find, how much more performance we'll find, but we have tons of ideas still. The other step is just bringing back a bunch of features like the shadow catcher and multi-device rendering and baking and all kinds of things that are missing. And as part of that, we're trying to bring them back in a way that's better than what we have before. When something's missing, it's usually because we think we can do it better. Like for the shadow catcher, we can take into account indirect light and things like this to have more accurate compositing with the shadow catcher. Another thing that we're planning to work on in the next few months is just sort of render workflow improvements. So you can sort of pause and resume renders, also final render, so you can save a render to disk and then just reopen Blender and continue rendering it, things like this. And then beyond that, once we sort of have most of the functionality back and we have in a better way, we'll also start investigating like better light sampling algorithms. Particularly, there's sort of three types of algorithms that we're looking at. Like one is better volume sampling using more modern algorithms for that, just to reduce noise in general and improve performance, and to just put like more advanced algorithms on the GPU. Then the other is like many light sampling for sort of complex scenes with many lights. And then the third one is more kind of a research thing, but we wanted to try looking into pad guiding to render things like caustics and interior scenes where light is coming in through a window and so on to render those kinds of difficult scenarios. What that regular pad tracing doesn't do so well. The last point is that, of course, the current implementation is missing OpenCL support. It's missing GPU rendering support on AMD and Intel GPUs, and we plan to bring that support back for those GPUs, but not in the current form. So we're trying to work with AMD and Intel. We're actively talking with them about potential implementations. They're looking into things. To make the new rendering kernels also work on those GPUs. And in general, I think if we have like the same architecture for all the GPUs and the CPUs instead of what we had before, where it was like kind of different for every device, it will put us in a much better place going forward. Yeah.
Wow.
That's it for me. That's the last slide of my presentation. Yeah.
That is freaking awesome. It's much more than what I was. Okay, I brought you guys back. I think now is the other guy here. So okay, cool. It's the internet. That's a lot. How long have you been working on this, and how long do you think until the end? I think you already mentioned it, but just to sum up.
Yeah, I mean, we've been working on this for about 2 months, Sergey and I, and it is sort of planned as a 6-month research project. But I think it will be, like 3-4 months or something until maybe it lands in a master branch, and then a couple more months before it's part of an official Blender release. That's sort of a timeline that we're thinking of. I mean, no promises, but that's sort of roughly the idea we have, in like 4 months before it's in master, maybe another few months before it's in the actual release.
So 3.1.2.
3.1, something like that. Yeah. Yeah.
That's crazy. So all of these optimizations, there are you mentioned a lot of GPU optimizations. Is it also affecting is CPU faster with this?
It's about the same currently. I think the new architecture, like, it opens up new possibilities to better take advantage of CPUs, especially like SIMD optimizations to instruct to do multiple operations in parallel. But we haven't focused on that yet. One thing that is nice, that can already give performance improvements, is the fact that there's no tiles, and we can actually schedule like individual pixels to different threads, so you don't have like one slow tile remaining. Like all your cores will be working together on every pixel.
But there is already that kind of rendering is also available in the current cycles, but it's slower. What makes it faster? Is it better scheduling or?
Well, I mean, this specific example I was giving with like a few, sometimes in CPU rendering you have a few tiles that are stuck, and you can already enable progressive sampling in cycles final rendering, but it's actually often slower than tiled rendering. And with this new architecture, it's usually faster. I mean, so it doesn't really have those bottlenecks anymore, where we need to do tiled rendering to get better performance. You can just sort of immediately see the first few samples for the entire image, and the performance is still just as good.
Yeah, I like that you mentioned that that you're not lacking ideas in how to make this faster, because I guess some areas are still missing, like volume rendering or multiple GPU. Adding support for volume, is that gonna make it slower, and what we see now is faster and then it's gonna be slower? Or
I mean, well, it's hard. It's sort of hard to say. Well, I mean, the comparisons we've made now, right, are scenes without volumes, and we think if we add back volume support in this kernel, like, it will basically have no impact on those numbers.
So if you don't have volumes, it's more specific. If you don't use SSS, don't compile.
And so if you do have volumes, then we hope that the new rendering algorithms will reduce noise and will give you better, improved performance also for volume rendering. So yeah.
Wow. Pause rendering also, that's one of people have been asking for. And what about the other patches that are around Blender at the moment that people have been waiting for, or that are being developed already? Are they compatible with this? If they're separate, do they have to be rewritten from scratch?
It depends. Like most of it you can adapt to the new architecture. It's not that big a deal on a technical level. Yeah, I mean, it's more like some adaptation is needed, but there's also features that we can do, like things like light groups. We could do them in the old architecture, but it has quite bad implications for things like memory usage. Whereas in the new architecture, we can do it in a way that's more efficient.
So light groups, light linking also.
Yeah, light linking is kind of independent of this, but I know it's like a very often requested feature. So we'll work on that to put it in one of the next releases. It's kind of independent of this project, but that's high on our priority list as well. Yeah.
And somebody mentioned adaptive subdivision, the forever experimental feature. Is experimental staying? Is it going away? Is it?
I mean, we want to finish it, but it's sort of not part of this project. So we don't. That's one thing we don't have a specific date for. We're focusing on this thing first, and then we can go through.
Yes, I think
do something like adaptive subdivision, which is a bigger project. Yeah.
Adaptive subdivision, caustics, I guess, also is a big one.
Yeah, I mean, with the path guiding, I would try to want to experiment with. I hope we can, support rendering caustics well. But it's the thing is, it's kind of a research thing as well, because this is sort of a method that's been used in production, in film studios. And it works well for that compared to some other algorithms that can do caustics, but it's not known exactly how to make it work well on the GPU. So we hope that we can, find a way to do that.
Wow. Is there any downside? It's like anything is worse than before? Is it?
I mean, there's lots of things missing, right?
Older hardware.
But
Does it support the same hardware as before, or do we need a newer graphics card, or it's just the same?
I mean, I think it will support the same hardware. Like the current version only has NVIDIA GPU support, right? And it supports all the same NVIDIA GPUs as before. When we add back support for AMD and Intel GPUs, I don't know exactly what that will look like, because I don't know exactly what the implementation will look like. But I don't think it necessarily involves different hardware support. I mean, we'll see.
So if it worked in the past, it's gonna work on release. It should, with the same version.
Well, I mean, for NVIDIA and GPUs and CPU, yes. For AMD and Intel, you know, we don't know yet exactly, basically. Yeah.
And I guess for Apple, we know the M1 build is also already in the build bot even. So yeah. M1 is being worked on by people from Apple.
Yeah, I mean, the M1 that we have in 2.93 is related to just CPU rendering. And so GPU rendering on Mac is currently missing in cycles, but we do think that, like, with this new architecture, it's more sort of agnostic about specific hardware, and it sort of has a thinner. It's easier to add support for more types of GPUs. You know, like true metal on macOS, for example. So it will be easier in the future to do this kind of thing. Yeah.
That's so cool. Well, I think I'm just curious on how do you guys, like, more on the other side of the development of Cycles X. It's like how did it start? Like how did you just think it's like, okay, now I'm gonna make a new Cycles, and how do you divide the project in two for you guys to work on? How did it started? Like, you were just one evening, it's like, I'm gonna make a new Cycles.
Well, I mean, Ton challenge, hey, go do some research project for some strategical project, which will bootstrap some development fundamentals for the next 10 years. So the first week after that, we actually spent quite some time with Brecht listing possible projects we can work on, analyzing them from how impactful they are, how fun it is to work on them, things like that. And it just turned out that Cycles is one of the projects where we wanted to work the most, and that we believe that we can deliver the most like the bestest possible product, so to speak. And for the dividing the work between us, it just happened to be so that Brecht knows the current state of the kernel better, so he stays from the surrendering kernel sides and works from that side, and I take care from what happens between Blender and the kernel, the viewports, the
dependency graph.
No, we are fully living in a cycle, so we don't really cross the Blender boundary that much. There was something to integrate it differently with the draw manager, make it more friendly for the multi-threading, so that the Cycles fully lives in its own thread without bottlenecking the viewport. But we so far fully living in Cycles. Eventually, the scope will be extended to Blender side more to support the resumable renders, support some other features. But so far it's all in the Cycle side, and it just happens quite naturally. So Brecht just works on the path tracing. I work on some of the adaptive sampling, the viewports, all the other things which needs to be there to support the functionality we plan. Sometimes also go to the kernel, but that's minimal things.
Do see yourselves working like grabbing another project and then, okay, let's do it from scratch again? Or you think other developers, how was the experience so far? Is it something that you would say like, hey, there's these 2 developers, go grab the compositor and rewrite it from scratch, or other areas of Blender? Or do you think that because Cycles is more standalone, like a separate thing, it's easier?
I mean, it's possible for other projects as well, I guess. I mean, for this, it's fairly easy in the sense that we both know this code very well already, or at least parts of it. So yeah, I mean, it's fun anyway to be given the opportunity to sort of focus on actually writing, code. Whereas like previously we were doing maybe more things, maintenance or
managing
smaller projects. Like doing something more ambitious is definitely rewarding. Yeah.
Wow.
I would also say that it's not only because you're back to code, it's also very nice to see the results which we can bring to users. That's a huge part of the motivational part of such kind of projects.
That's so cool. And also because you really went all in, we've seen that there are ways to hack Cycles in a way that it renders faster for specific hardware or at the cost of precision, but this really looks like you guys rewrote the entire thing for speed without those hacks.
Yeah, it's sort of those hacks kind of can sort of partially address the problem, but by building sort of an architecture that sort of natively is designed to exploit like the GPU performance in a way by sorting things and making sure like execution is coherent. I mean, it's pretty technical, but this generally it helps to give the GPU a lot of work that's similar in batches. And so yeah, we're trying to sort of handle those problems, sort of head on instead of trying to kind of work around them or trying to do some little tweak here or there. Yeah.
And this is fully compatible with Cycles, right? There's no the works that our blend files the materials don't need to be updated for it.
No. I mean, there might be in the end, some render settings that you might want to tweak again in terms of, adaptive sampling or sample settings or things like this. But generally speaking, like you're seeing, should just still render, the same as before.
Even with less settings, right? There is no tiles, no.
Progressive. I mean, we were trying to eliminate as many as possible, but not too many, of course, because people still want control.
Yeah.
Anything that's go ahead.
Like other thing, it's every setting which you cannot eliminate. We want to also revisit the presets, the way how presets work for Cycles, and make them really easy to use and easy to discover.
Yeah,
and not only limit them to specific things, like preset for the light bounces, to things something more global. Like this is the preset for the preview, and it will tweak whatever we believe is the best for the previews, no matter if it's light bounces or is it some approximations here and there, and things like that.
It's definitely the way to go. Brecht recently did some updates in the presets for FastGI, and it, like, by looking at the code and the commit, it was just reshuffling things, actually exposing it more that used to be on Simplify. Now are part of the
just exposing a feature somewhere else in the user interface can. Like I've seen users just noticing the feature now or starting to use it just because we moved the location of where it is in the UI, which makes sense. Of course, usability is important. So yeah,
definitely. There is a blog post just for people that want to read more. There is. I'm gonna reshuffle you guys. There is a blog post, right? That's gonna go out soon. With more explanation about how to get it eventually, the graphics that we've seen, and more of the write-up. But yeah, looking at this,
yes,
That's insane. So the BMW takes as long as a full production shot from the Asian 327.
Well, I mean,
Hey,
no.
barbershop.
That's not what I would read from the graph. Like we've basically made the render times, all kind of similar, so they fit in the same graph. It doesn't necessarily mean that the noise level is similar.
The noise level. Okay. The noise.
No,
level.
it's just we just sort of fit them, tweak the number of samples so they all fit nicely in a single graph. So it doesn't. Yeah.
This is awesome. So, is there anything else you want to add? This is really.
Not really. I mean, I would like to thank like everyone who's contributed to Cycles in the past 10 years. Both developers and users and everyone who's made beautiful artwork with it. And I just hope we can continue doing this for the next 10 years.
Oh, isn't that
That's
nice?
a good word.
Yes, you Sergey, you have to top that.
Oh, that's quite hard.
Yeah.
But you can't top that. But yes, thanks everybody.
Well, thank you for working on this so hard and just thinking that just suddenly opening Cycles and rendering is just faster, just by not doing anything. But you have to do all the work, and then suddenly it's faster. It's just amazing. So yeah, wanted to thank everyone, and thanks to also to the Blender Development Fund subscribers, because you guys are working for Blender, so that pays the bills. But also for people to share these news, to get excited for the hype. Sorry for building so much hype this week. I think we've never done this amount of hype, not even for Blender 2.8, I think. But with the X and the people, what is the X? And that was super cool. Sorry if we added stress to you guys, but now you can go relax, enjoy the weekend, the week, and take your time with this. What you've shown with this already, it's insane. So no rush. Yeah, I guess the community can. You mentioned the Brecht that can help with in the future, now that the foundations are.
Yeah, I mean, so over the next, I guess the start of next week, we'll start, creating tasks on developer.blender.org to just make it clear what the current state is, what needs to be done, and so on. And at that point, once that's there, developers could start getting involved. But give us a few days to deal with that.
Take your time. There is plenty of other things going on around Blender to get excited about. But Cycles X, Cycles 10, how do you call it? X10?
We call it Cycles X, but I mean, it's just a code name for the project. Once it folds back into Blender, it'll just still be Cycles, of course.
Just pure Cycles. Yeah. Awesome. Well, builds are gonna, for people in the chat, builds are gonna be available ish soon. Remember that there's many areas missing. Multi GPU, for example, is not working at the moment. Only one GPU. No volume rendering. So when I was testing it locally, I had the Blender with multiple GPU, and then this one we did it, and I was like, why is it? Yeah, of course, you're using 2 GPUs instead of 1. So keep that in mind for people in the chat. Okay, that is all. Thank you, Brecht. Thank you, Sergey. Thank you, Francesco, for helping out, and everybody at the studio. Simon, they made an image today. Don, for giving you guys the time and a salary for this to happen. Everybody at the studio, everybody in the chat. So it's super exciting. I just want to say goodbye. So well, I don't know if you know I don't know if you watch probably not watch Blender today, but at the end we always leave with a little bit of style in the shape of Street Fighter 2 theme of Gille. I don't know if you get to hear. Yeah. So Thank you guys for staying here. Thanks everybody online. I'm gonna see you on Monday at the same time, same place for another episode of Blender Today. Bye.